Okay, here's another example. Trying to just come up with maybe some challenging derivatives that people are having trouble with, and just give you some more derivatives to look at, because I know you're all going to be diligently practicing derivatives over the weekend. So the first thing I would do here is I would clean it up a little bit. For example, I can take the cube root of 27, which is 3, because 3 times 3 times 3 equals 27. And then on the bottom here, I would have x squared plus 5x minus 1 to the 4/3 power, because of the cube root goes on the bottom of the fraction and the 4th power goes on the top. And then we can actually write this simpler. The 3's actually cancel out. So that would be, then I could write this as x squared plus 5x minus 1 . Okay, so, and we're going to write that to the negative 4/3 power. So again, the 3's cancel each other out. That's why there's just a 1 there. So I've written it. Okay, so now I'm ready to take the derivative. So dy dx would be negative 4/3 times x squared plus 5x minus 1. We drop the power 1, that'd be negative 7/3. And then so that was the derivative of the outside layer. Again, the outside is just something to the negative 4/3 power, so we've done that. Now we have to multiply by the derivative of the inside. And so the derivative of the inside would just be 2x plus 5. And you could leave it like that. Well, actually, you probably should distribute the negative 4/3 through there. So, you could write this as, let's see, negative 8x minus 20 all over 3 times x squared plus 5x minus 1 to the 7/3 power. That would be one way to write it. Probably maybe the cleanest way to write it. Or you could, if you wanted to, just distribute the negative 4/3 through this parenthesis and then just leave it as a negative exponent. I'll do another example. How about this crazy one? X squared e to the square root of sine x. So dy dx. This product rule, of course, because we got something times something, and both somethings involve an x. So the derivative, this would be my u, this would be my v. So u prime would be equal to 2x, and v prime would be equal to, the derivative of e to that is e to that, times the derivative, the square root is the next layer, so that would be times 1/2 times sine x to the negative 1/2, and the derivative of sine x would be cosine x. Ooh, that's a beauty. Okay, so dy dx, we need u v prime plus v u prime. Okay, so u is x squared, and v prime is all of that stuff. Let's see, consolidate it along. I'll probably put the 1/2 out front, and then the e to the square root of sine x times cosine x, and then put all that underneath that. I'd put the square root of sine x, because the negative 1/2 would mean put on the bottom, and the 1/2 would be square root. Okay, and then add to that v, which is e to the square root of sine x, and times u prime, which would just be 2x. So actually, I think I'll put that in there. I'll just leave it there. Times 2x. Okay, if we wanted to clean things up a little bit, you could go, this would be x squared cosine x e to the square root of sine x. The order doesn't really matter there. And then on the bottom, I put the 2 times the square root of sine x plus e to the square root of sine x, and probably put the 2x up front. And that would be good.